Prior to exam 3, I noticed that one of the most challenging concepts was picking which reaction to use because of the sheer amount of reactions that we had learned. And when I took a look at all these reactions, I noticed that most of them dealt with alcohols. Alcohol reactions are very important because they are often used as an intermediate step in synthesis reactions. The first thing we learned about was changing an OH into a better leaving group. Our first option was using a strong halide acid to yield an alkyl halide. The problem here was that secondary and primary weren't as reactive as tertiary. Secondary alcohols required heat, and so did primary, but they also could use zinc chloride. And the problem here is that heat in a strong acid is a very hostile environment, so it's not ideal. So, one of the better options was to use PBr3, PCl3, or SOCl2 to yield an alkyl halide. This worked much better for primary and secondary alcohols. The only stipulation was that it was carried out in pyridine. Our third option was to create sulfonate esters using tosyl chloride, mesyl chloride, or trifol chloride. These also were to be carried out in pyridine. The next category of reactions are dehydration reactions. And as we had learned hydration reaction with H2SO4, you can carry out the opposite reaction using concentrated H2SO4 and heat to dehydrate an alcohol. The problem here, just like with using strong alkyl halides in heat, is that heat and a strong acid are hostile in conditions. So if there's a better option, it's best to use it. There is a better option, and it's POCl3 in pyridine. The third category of reactions are hydration reactions, or adding an OH group to an alkene. The first option was acid catalyzed using H2SO4 and water so that it was dilute, or the opposite of the dehydration we just went over. The problem here is that it's subject to carbocation rearrangement, so you can't always be sure about where the OH group would add. So a better option here, if you're looking for the anti-Markovnikov product, is to add a 1/3 equivalent of BH3 followed by H2O2 and OH-. And like I said, this would give the anti-Markovnikov alcohol. Third option for hydration to create the Markovnikov alcohol is to use mercuric acetate with H2O and THF followed by NaBH4. And this would add, like I said, as a Markovnikov product on the more substituted carbon. It's important to know these reactions since they are often used as an intermediate in most synthesis that we do. Thank you.